So the data in the chart show the cost of tuition at a state university for the years 1997 through 2001 fit a regression line to the data where X is the number of years after 1997. So rather than having to input, and let me make this a little bit larger. Rather than having to input 1,997 for 1997, we want to input 0 for 1997. It's just easier to manage if we want to look at the graph. We don't have to set our viewing window to X goes between 1,997 and 2001. We can just go X equals 0 to 4. It's much simpler that way. So let's get to the calculator and see exactly how to do this. On the calculator, I'm using, it says TI-84 plus, but this operating system is the older operating system. So if you're using the TI-83, it's going to seem a lot more like your calculator. If you have the TI-84 plus or a subsequent iteration of the graphing calculator, there'll be a screen we get to at some point where it won't look at all like what I have on my screen. I'll try to walk you through that as well. So to get there, to enter these basically ordered pairs, X equals 0, Y equals 9,788, you want to press the Stat button. After you press the Stat button, number 1, we want to edit a couple of lists. So you can press number 1 or simply press Enter since it's on 1 for edit. So basically the Stat button followed by the number 1 takes you where you want to go, where you see the L1 at the top and the L2 at the top of the next column. If you already have numbers in these lists, like if you've got a 5 and you've got a 9, something like that, one way to get rid of those numbers, I guess I didn't put the 5 in there. One way to get rid of those numbers is to delete them one at a time, and that's fine unless you've got 100 numbers in there, in which case it may take a while to delete them one at a time. If you have a lot of numbers in there, somebody's used your calculator before, and you just want to clear them all out all at once, I would recommend not using the delete button, but instead pressing the up arrow up to the L1, and again, I recommend not using the delete button. If I press delete right now, the L1 will go away, and there'll only be an L2 and an L3 and an L4, and then panic will set in wondering, how do we get the L1 back? Just press clear. Press clear. Now it looks like nothing happened after pressing clear, but if you follow that with pressing the down arrow, then the list has been cleared. In case you have the misfortune of accidentally deleting one of your lists, say we come up here and it's over there at L2, and you press delete, and L2 just vanishes, and we're wondering where to get it back. No need to panic. If you press the second button, make sure the L3 is highlighted because we're going to put the L2 right in front of that. Press the second button, and then press the delete that has the INS for insert right up on top of that. Press that one, and then you have to indicate what the list name is. If you look down on the 1, 2, 3, 4, 5, 6 buttons, L2 appears in blue or perhaps yellow for TI-83 plus users up above the 2. So let's see, it's already got the alpha there, so I don't think I need to press. I don't want a Z there. I think I want second 2. Yeah, that's what I want. You need to press the blue second button followed by the number 2 and then enter, and there it is. So it puts the L2 back. So hopefully you don't accidentally delete any of your lists, but if you do, you can reinsert them and it'll be fine. Let's put the 5 numbers in the L1 list, the 0, 1, 2, 3, 4. So 0, enter, because it'll work its way. It's better to enter the numbers in a single list, pressing enter each time. You could press the down arrow each time if you want to, but I would suggest pressing enter each time. Then press the right arrow to go over to the L2 list. And then there's more to enter there. 9788. And then the down arrow, 10,000. 556. And when I'm pressing the down arrow again, I could just press enter. There we go. 11,106. Enter. 11,602. Enter. and 12,177. Again with the enter. So we've got the ordered pairs. Glance at them, just kind of double check, because it will throw off the answer if we're off by even a 1 or a 10. Any questions at this point? Emma, yes.
Okay, so I'm like typing them in, but I typed in something wrong, just on one of the lines, and
Okay.
clear and delete it.
Well, you can navigate to it using the arrow buttons. You can press the up and the right arrow. If you press the left arrow may take you to the bottom of that previous list. Does that get you where you need to go?
Okay, yeah.
Up and down, and right arrow. Okay. I'm going to press second quit just to get out of this screen. So second button, and then the mode button has the word quit up above it. A lot of times if you press second mode or second quit, it'll get you out of whatever you're into. So, so we're out of that. Now, I'm going to go ahead and have the calculator calculate the equation of the straight line that comes as close as possible to as many of these points as possible. So basically we have 5 ordered pairs. We've got 0 and then 9, 7, 8, 8, and then over to the right, and then up a little bit, there's 1, 10,000, 5, 5, 6, and then over to the right a bit, and then up a bit, there's 2, 11,106. If we tried to sketch a straight line through those points, we'd probably come close to this equation, but the calculator will calculate what's called the linear regression equation, which is the equation of the straight line that comes as close as possible to as many of these 5 points as possible. So press the stat button, and then press the right arrow. We want to go to the calculate menu after pressing the stat button. So the right arrow takes us to the calculate menu. Lots of different options there. The one we want is number 4 on the list, which will give us the linear regression equation. So stat button, right arrow, number 4. You could press 4 or press enter after scrolling down to number 4. Now, when I press enter, your calculator is going to look different. The screen on your calculator is probably going to look different from what mine does. Mine just says linear regression, and it expects me to press enter and then go. There's some additional information that I can tell it. I can tell it, you know, I've got a bunch of lists, L1, L2, L3, L4, L5. One of those lists holds the x coordinates, and the other list holds the y coordinates. Maybe my x coordinates are in L3, and my y coordinates are in L5. If that were the case, what I would do here is type second L3, or second and then the number 3, and tell it my x coordinates are in L3, and then type a comma, and then tell it my y coordinates are in L5, and then press enter. But I don't want to do that, and in fact I think this one has been used before to calculate a situation where the x coordinates are in L1 and the y coordinates are in L2. So if you're using the TI-83 Plus, you probably don't have to type the L1 comma L2 here. If you simply press enter, it's likely to go ahead and calculate the correct linear regression equation. Now, you have a newer calculator, and it's got a screen where it says what, X list? The X list, and on the X list, thank you. The X list, it's suggesting L1 probably, and the Y list, it's suggesting L2. The frequency list, if it's suggesting anything, delete that, clear that. You don't want it to. The frequency list, in case there's some ordered pairs that appear multiple times, and you didn't want to have to type those in multiple times, you could have another list called a frequency list to take care of that. You don't necessarily need to store the regression equation, although we could simplify things a little bit if we wanted to graph it. Scroll all the way down to calculate. If you've got L1, L2, scroll down to calculate, and that'll accomplish the same thing. Thank you. That'll accomplish the same thing as simply pressing enter here. And let's see if we get same answer. Did you get A equals 582.4?
Yes.
And B equals 9,881?
Yes.
Yes. Okay, good. Did anyone get an R squared or an R?
Yes.
Did you get an R squared or an R? The correlation coefficient. Basically, for linear regression, if the absolute value of the correlation coefficient R is really close to 1, then the points are really close to being all on the same straight line. And if the absolute value of the correlation coefficient is close to 0, the points are all over the place. Now, you can't draw a straight line that doesn't miss at least some of the points by a good bit. Let's find out how to do the correlation coefficient. So press the second button, followed by catalog. Catalog is on the 0 button. So press second, 0, and then press the, let's see, the down arrow. We're looking for diagnostic on. Diagnostic on. There it is. I want to press enter. And I want to press enter again until it says done. There. So repeat the process of calculating the linear regression equation. Press the stat button. Everyone successfully turned the diagnostic on, or run that program diagnostic on. Okay. Press the stat button. Press the right arrow. Oops. Right arrow. There we go, to the calculate menu. Scroll down to 4 and press enter, or simply type 4. And it should be simply a matter of having the calculator now calculate the linear regression equation. And now there'll be an R squared and an R. So when it asks us for the correlation coefficient to however many decimal places we need it, there it will be. 0.996 something is very close to having an absolute value of 1. If the correlation coefficient is positive, it simply means that the points are arranged on a straight line that has positive slope. It's not the slope, but if it has the same sign as the slope. If the correlation coefficient had been negative 0.9, then it would indicate that's a good negative correlation, but a good strong linear fit. It's just that the line has negative slope. So we'll keep this in mind. And multiple choice, the A represents the slope, because it's y equals ax plus b. The B represents the y-intercept. So I'm thinking D. Y equals 582.4x plus 9,881 is the equation of this straight line. So if I can get back to here, I'm going to select D and check answer. So far so good. Press OK. There it is. Thanks for the heads up on that correlation coefficient. Round to the nearest thousandth. 3 decimal places. 3 decimal places. So 0.997. There we go. Is the regression line a good fit? Basically, if that number has an absolute value close to 1, and it does, it's a good fit. If it's close to 0, it's not a good fit. In between, what, 0.5? Is that close to 1 or is it close to 0? Well, there's a procedure, a clearly laid out procedure that we do in statistics based on the size of the sample, that is how many ordered pairs there are. If there are a lot of ordered pairs, that correlation coefficient doesn't have to be as close to 1 for it to be classified as a good linear fit. If it's just a handful of ordered pairs, the correlation coefficient has to be closer to 1. But I'll look at the next 2 examples as well and see if there's a situation where it's not a good linear fit. Final check. If we had to plot these points on our own, we could do that. I'm going to see if I can get the calculator to plot them. Now, here a word of warning. What I'm about to do could cause some tremendous frustration when it comes to test time, because I'm going to turn one of the stat plots on, and as long as you've got numbers in your L1 and L2 list, that shouldn't produce any errors. But if the stat plot is turned on and the L1 and L2 list ever get cleared, it'll result in what's called an invalid dimension, or invalid DIM error. And it's terrifying, because you try to graph something on your calculator and it just won't graph. All it'll do is give you this invalid dim, or dimension mismatch is another possible error. So we'll make sure to turn the stat plot off before we leave today. So here goes. Second button followed by y equals. where the stat plot is. Number 1 on the list, plot 1. I'm going to press the number 1. That's the one we'll activate. I'm going to press enter to turn that stat plot on. And there are half dozen stat plots to choose from, line graph, frequency histogram, got a couple of box and whisker plots. Just going to leave it on the first one. The very first one right there is the scatter diagram, and we just want it to plot 5 points. That's all I want it to do, so I'm going to leave it on that. My x coordinates are in an L1 list, so that's good. The y coordinates are in an L2 list, so that's good. And for the mark, I like a square rather than a dot, because what I want to do is follow this up with having the calculator sketch the graph of this straight line, which we think is such a good linear fit here. And if it, if it actually includes one of those points or gets really close to it, it'll cover it up and we'll forget where that original point was. But if it's a square, even if the line goes right through it, we'll still be able to see where that original point was. So I like the mark as a square. You can do a plus or dots if you want to, but I would recommend the square. Seems okay. Now, second quit. I'm going to press the y equals button. Maybe I've got something there. It looks like I graphed some sort of equation for a different class. I'm going to clear that out and have the calculator graph what the linear regression equation it calculated for us. Y equals 582.4 times x, using the xt theta n button, plus 9,881. Very steep and a tremendously high y-intercept. Currently, my calculator is close to the standard viewing window, not exactly in the standard viewing window. There's no part of this graph, I can imagine, that's going to be within the standard viewing window. If it is, it's going to look like it's zipping straight up through it. With the plot 1 activated, if we press zoom, followed by, I want to say it's 9. Zoom 9, with the stat plot activated and numbers in the L1 and the L2 list, zoom stat will automatically reset the x-min and the x-max and the y-min and the y-max, so all 5 of these data points will appear on the screen. Now, if this is a good straight line, that straight line should come fairly close to going through all 5 of those points. So here goes. I tell you what, for dramatic effect, I'm going to turn off the straight line. I'm going to go back to y equals, and I'm going to move the cursor over to where it's flashing on the equal sign there and just press enter. That turns that off momentarily. And then I'm going to press zoom 9. Zoom, and I'll scroll down to it, but just zoom 9, we'll get there. Enter. So those are the 5 points that we plotted. Now, turn that equation back on, y equals, and it should go through those 5 points, or real close to it. There we go. So the first couple, it goes just below the 2 points. Then actually, the y-intercept, it goes just above that point. The next 2, it goes below the 2 points. And the next and the last 2, it looks like it goes just above those 2 points. So there are other straight lines that we can draw, but this, without being overly technical, this line is the one that comes as close as possible to these 5 points as possible. Let's see, I'm going to go ahead and turn the stat plot back off. There's a faster way to turn the stat plot off than the procedure we used to turn it on. If you just go to the y equals screen, you'll notice plot 1 is highlighted in the extreme upper left. If you press the up arrow and simply press enter, that'll turn it back off. So now if I press graph, I've still got the straight line, I've got the same viewing window, but it no longer plots those 5 points. And now if I were to clear either one of those 2 lists, it would not give me a dimension mismatch error or an invalid dimension error. Oh, let's see. No, I guess I don't want to lose it. the predicted cost of tuition in 2008. 2008 is how many years after 1997? If 1998 is 1 year after 1997, then I guess 2008 would be 11 years. So I'm thinking I would need to take 11 and evaluate this expression y equals 582.4 times 11 plus 9,881. So 582.4 times 11 plus 9,881. 16,287.4 or $16,287.40. 16. Get back there. There we go. To the nearest dollar. There we go. And that's probably a lot more precision than that's actually warranted. I would think to the nearest $1,000 would make more sense for an example like this, but we'll go to the nearest dollar. Okay. Are we there yet? No, we're not. But unfortunately, I skipped over the last part of that. There was one part remaining to that. Of the other two, don't think I want to take time for both of these, but of the other two, anybody struggle with one or the other and would prefer to see either the life expectancy problem or the resting heart rate problem? Do I have a preference? Maybe none of the above? Okay.
I just have a question.
Yes.
So I was wondering what a bad correlation or display consistency in data looks like the R.
Well, if you want to make it as bad as possible, if you just want to make it just really terrible, here's how you do. Zero correlation. There we go. If you want zero correlation, input the coordinates of a square. Input the origin. Input, how simple can we make this square? 0, 1, 1, 1, 1, 0. Now if I'm going to draw a straight line that comes as close as possible to as many of those points as possible, what straight line am I going to draw? I'm going to draw that one. Am I going to draw that one? What about that one? Or maybe that one? Or something like this? Yeah, any straight line that I draw, you can say, well, what about something else? And it would be equally good and maybe have the opposite slope as the one that you might draw. So zero correlation, if you input, let's see if we can do this here, stat, edit, keep the 0, keep the 1, go with another 0 and another 1, and delete that entry, delete that entry. So if we go 0, 0, 1, 0, 0, 1, and 1, 1, I think those are those same 4 points, maybe not in the order in which I listed them. Second, quit, stat, calc, 4, enter. It suggests that we draw the straight line with slope 0 and y-intercept 0.5. So it actually goes with none of these it suggests that we draw this straight line that comes as close as possible to as many of these points as possible, but it characterizes this as zero correlation. The correlation coefficient is 0 in that case. If you want the correlation coefficient to be 1, then the thing to do is, I guess, perfect correlation. Perfect positive correlation. Then any collection of points that are collinear. You would go with 0, 0, and with positive slope. 1, 1, and then 2, 2. So stat, edit, 0, 0, 1, 1, 2, 2, and then delete that. Living dangerously here by deleting these items, but I don't want to clear the list. Any 3 points that all lie on the same straight line that happens to have positive slope. And second, quit. Have I shown you the second entry button? Second entry, if you press the second button followed by enter, second enter, it'll bring back what you've typed previously. So if you don't want to go through several steps to get whatever that was that you typed, it'll bring that back, and then you can just re-execute it. This is y equals 1x plus 0. So y equals x is the equation of the straight line that goes through those 3 points, and the correlation coefficient is 1. If you want it to be a straight line, but with the correlation coefficient of -1 on the other extreme, just make sure it's a line that has negative slope. Stat edit. Let's go with what? 0, 2, 1, 1, and 2, 0. That would be 0, 2, 1, 1, and 2, 0, something like that. Must have been up there somewhere. Second quit. Second entry, and that's the line y equals -x plus 2, y-intercept of 2, slope of -1, and the correlation coefficient is -1. Correlation coefficient, again, doesn't correspond to the slope, but it has the same sign as the slope. So that would be perfect negative correlation. I suppose I should erase that much of it. So those are the extremes. Let me find the problem then in 1.5. It's not quite as extensive as this particular one. Okay. Maybe 12? Leave. Let's see what we got. So it actually displays the graph. This problem can be a source of frustration since it's an instructor-created question. I actually made it up myself. It doesn't have the show me an example, help me solve this. It just has the ask my instructor button. So what I'll do, hopefully this video will come out okay. And if you have a question about it, I'll refer you to this video, unless it's a short question I could answer without having to kind of redo the problem. So basically it gives you the data points and then asks you to input the linear regression equation in the form y equals ax plus b. The y equals is given, we just need the ax plus b part. And it goes like this. Stat, edit, 11, 28, 39, 42, 52, 60, 75. And then press the right arrow to go to the L2 list, and I'm just overwriting the list. Make sure I go all the way up to the top. 34. go. Quick look to double check that those are the same as the ones that were given. Seems okay. Second quit. And then looking at this one from scratch, once the data are in there, I would press Stat, and then press the right arrow to the Calculate menu, and then number 4 for linear regression. And if I'm confident it's looking at the L1 list for my X values and the L2 list for my Y values, I'll simply press Enter or Calculate. And I'm going to have to round. Y equals, the slope is 0.49, so I'll go with 2 decimal places there. And the y-intercept is 24.76. Go with a couple decimal places there as well. So y equals 0.49x plus 24.76, and hope it likes it. $24.76. Okay. The next question, you don't have to calculate the linear regression equation. If you do, hopefully you come up with y equals 0.43x plus 27.77. But that's given. The picture is given, the data are given, but you don't have to go through the process of calculating it because the linear regression equation is given as well. What you do need to do, though, is take the value y equals 49 and ask yourself, if we're trusting this linear regression equation, what value of x would go with that so that that would be a point that's pretty close to being, in fact, exactly on this straight line. So it amounts to substituting 49 for y and then solving the equation for x. And then rounding to 2 decimal places. The print a little bit bigger. Maybe it'll let me write on this. Substitute 49 for y. 49 equals 0.43x plus 27.77. And solve the linear equation for x. 2 steps. Subtract 27.77 from both sides. And we get 21.23 equals 0.43x. When we divide both sides by 0.43, x is approximately 49.37. 49.37. And when we input that, hopefully it's going to like it. $49.37. And it does. The next one, a variation on the same theme. Again, the data are given, the picture is given, but the linear regression equation is also given. So it's not necessary to type the data in and calculate the linear regression equation. All you have to do is substitute 36 for x in the equation that's given, and this one doesn't even require you to solve an equation. If you substitute 36 for x, it's a matter of evaluating the expression, and you evaluate that expression and round it to 2 decimal places, and it should be okay with that. So y equals 0.42 times 36 plus 27.04. So 0.42 times 36 plus 27.04, and it's 42.16. And hopefully that kind of makes sense. If we don't have a data point with an x-coordinate of 36, but if these are all pretty much on the same straight line, we would think if we had one that 42 point something would be about where the y-coordinate should fall. It just seems to make sense. So get rid of that since that wasn't actually a data point. But let's see if it likes 42.16. And it's good with it. Now, these hard problems are easy problems. Once you get the calculator going, you feel comfortable with how to make it give you the information that that you need. It should seem like fairly easy problems. So hopefully these won't be too bad. Let's look then at section 1.6. And for section 1.6, make sure I don't miss anything, because I want to be able to get through as much of this as I can in the next the next half hour. I want to follow along with a collection of MyMathLab problems. We'll cover topics of solving linear inequalities, topics that include solving compound inequalities, 3-part inequalities, an example or two where we look at the domain of a function that requires us to solve a linear inequality. So before we look, say, at question 3, let's begin with this 1.6 linear inequalities. 4 is less than 6. True or false? True. If a number is to the left on the number line, then we say it's less than, and this is the symbol that we use for less than, a number that's to the right on the number line. Now, if we were to take this statement and add, let's say we add 2 to both sides and compare 4 plus 2 to 6 plus 2, can we still say this? That whatever 4 plus 2 is, it's less than whatever 6 plus 2 is. Certainly, 6 is less than 8. And if we're adding the same quantity to both sides, this is it's going to give us an equivalent inequality. So we can do this. Suppose instead of adding 2 to both sides, we subtract 2 from both sides. Can we still write the less than symbol there?
Yes.
We can. Like comparing 2 quantities with a balance, and we remove the same amount if they were balanced in a particular way to start with, or if they were off balance, I guess I could say, in a particular way, they'll still be in that same direction. 2 is less than 4. All right. So if 4 is still less than 6, how about if we multiply both sides by 2 and compare 2 times 4 to 2 times 6? How do they compare? Yeah, still have a less than symbol. 2 times 4 is 8. 2 times 6 is 12, and 8 is to the left of 12. If we have 2 quantities and we double each one of them, multiply both sides by 2 or by any positive real number, then inequality stays the same. What if we divide both sides by 2? compare 4 over 2 to 6 over 2? 2 is less than 3, so no changes there. No changes. Where do the changes occur? If we multiply both sides by anything negative. Negative 2, for example. If we multiply 4 by negative 2 and we multiply 6 by negative 2, right at the moment that we do it, we have to reverse the direction that inequality symbol is pointing, because we're now comparing negative 8 to negative 12, and the numbers actually swap places on the real number line. You've got 4 is to the left of 6, but if you want to compare negative 8 and negative 12, you jump to the other side of 0, and now negative 8 is greater than, is to the right of that negative 12. So when we multiply both sides by a negative number, we reverse the direction of the inequality symbol. And if we had 4 is less than 6 and we want to divide both sides, let's say, by negative 2, we still switch it right at the moment when we do the division. So negative 2 is greater than negative 3. So keep that in mind. Solving a linear inequality follows the same steps as solving a linear equation. It's just a matter of, when we come up with the inequality as our final answer, how do we use interval notation to express the solution set? So for this one, six minus 3x is less than or equal to 2x plus 16. If I'm following the same strategy I would use for solving a linear equation, I would want to, well, ultimately I want to isolate the x term, but that means getting the x terms together on one side of the inequality, and all the terms that are not x terms, do not contain the variable, on the other side. You could go either way with this. If for whatever reason you like to keep your coefficients of x positive, it would certainly be fine to add 3x to both sides to get the x terms on the right. For the sake of illustrating that process where we divide both sides by something negative, I'm going to subtract 2x from both sides so that we have the x term on the left and then the terms that don't have x's in them on the right. So let's subtract 2x from both sides. We'll have 6 minus 5x is less than or equal to 16. And I'd like to isolate the x term. So there's a positive 6 on the left-hand side. Let's subtract 6 from both sides to cancel that 6, giving us negative 5x is less than or equal to 10. And at the next step, I like to include an extra step. I do this for equations as well as for inequalities. If we were solving an equation and we got to the point negative 5x equals 10, let's say, we would probably get by with just putting a divided by negative 5 divided by negative 5, and then x equals negative 2, something like that. But with the inequality, as soon as I draw a bar under that negative 5x and a bar under the 10 and divide them both by negative 5, I've got to erase the inequality symbol and reverse it right at that moment when I'm dividing both sides by something negative. So I don't want to have to do that. So I'm going to copy this statement and write a fresh copy of the negative 5x and a fresh copy of that 10, and then divide both of them by negative 5. And then reverse the inequality symbol, but it doesn't have to be reversed in the statement up above because I haven't divided both sides by negative 5 yet. Now, when we do this and we simplify, we get x is greater than or equal to negative 2. MyMathLab is going to ask for this in interval notation. On the test, I'm going to ask for an interval notation, but it's not a bad idea if you're just not clear how to write the interval notation to write it on the number line, shade it, and just kind of look at it and say, this is the portion of the x-axis, the real number line that I'm talking about when I write this interval. So -2 is where it is. So is this everything including and to the left of -2, or everything including and to the right of -2? Yeah. Want to go to the right here. So -2 is there. Back in the day when I learned how to do this for the very first time, I'm sure I'd put a solid dot right there at -2. Is that still taught, a solid dot there? And that's certainly fine, because I'm not going to ask you to graph this on the number line. So however it works best for you. What's typical, if you see this done in the textbook, I think what you'll see is a bracket there. It's kind of a square bracket to indicate that the -2 is included. That would correspond to a solid dot. You'd see a parenthesis if you would otherwise put an open circle if you did not have the or equal to bar there, if it were strictly greater than. But not really picky about how you draw the number line, or even how you shade it, but this is the portion of the real number line that we're talking about. These are the numbers that are greater than or equal to -2. To write this using interval notation, this translates so that -2 is on the left. That's the left-hand endpoint of that interval, and it's included in the interval because of the bracket that we use. Bracket means it's included. And then, what's the right-hand endpoint? Yeah, you could say, actually, maybe there's not one, and because there's not one, we certainly write that infinity. Now, infinity, why use a parenthesis rather than a bracket?
It's not a number.
It's not a number. Infinity is not a number, simply a symbol that we use to indicate unboundedness in a particular direction. So always a parenthesis next to positive infinity, always a parenthesis, if you need to, next to negative infinity whenever you want to put a bracket on the infinity. So if I want to take time to enter all these, but let's just make sure it likes it. So I can actually type the left bracket on the keyboard, and then a -2, and then a comma, and I need the symbol palette for the infinity. Just one of them. And a parenthesis, I should be able to type that as well. I'll check the answer and see if it has a follow-up. They're the graphs. So you don't have to sketch the graph, but you do have to choose the correct graph. So it looks like, is it A?
Yes.
Looks like A. Check that. And then on to the next question. Okay. Determine the domain of the function. We could probably stare this down. I think we've done a similar problem like this in class already in another section. We could probably stare this down and come up with the domain of this function just by choosing some numbers and see what works and what doesn't work. How about, I see a 4 there. So how about 4? If you substitute 4 for x, do you get a real number for y? 4 minus 4 is 0. What's the square root of 0? 0. 0 is on the real number line. So it's real. So 4 is in the domain. How about 5? Is 5 good? 5 minus 4 is 1. The square root of 1 is 1. So that's real. So 5 is good. What about 6? 6 minus 4 is 2. Square root of 2 is 1.414 something, 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 something. It's irrational, but it is very much real. You can go to the real number line and put a dot just to the right of 1.414 something, something, something. And it'll be there on the real number line. So 6 is in the domain. 7, 8, 9, 10, 11. The greater you get, if you subtract 4, you're still getting numbers that are at least 0. And when you take the square root of something that's at least 0, you get something real. What about x equals 3?
No.
That's a problem. 3 minus 4 is -1. Square root of -1 is, well, it's imaginary. We would like our functions to be real valued in this class. So just kind of by staring at this thing and figuring it out, I think we've arrived at the conclusion that x has to be greater than or equal to 4. A couple of steps above that, you would say x minus 4 has to be greater than or equal to 0, actually just one step above that. After you add both sides, 4 to both sides, you get x is greater than or equal to 4, and in interval notation, it looks like this, 4 to positive infinity. We can probably find a more challenging problem than this, though. We make sure it likes it and that there's no follow-up question. 4, comma, infinity, check it, no follow-up question. Okay, this one's a little bit more complicated. Let's look at this one. This f of x equals the square root of 3 minus 4x plus 3. The plus 3 is not going to impact the domain. That'll impact the y value. If we get a real y value, when we take the square root of 3 minus 4x, we're going to add 3 to it. But adding 3 or not adding 3 doesn't affect whether y is real or not, just what the exact value of y is. We're going to get a real answer if we try to take the square root of 3 minus 4x, and 3 minus 4x itself has what relationship to 0?
It has to equal 0 or above.
It has to equal 0 or above. It can't be less than 0. If this is less than 0, its square root is imaginary. If it's 0, its square root is real. If it's greater than 0, its square root is real. So you take whatever's up underneath the radical sign and declare that to be greater than or equal to 0. Solve that inequality. That's the domain. Okay. So subtract 3 from both sides, and negative 4x is greater than or equal to negative 3. Divide both sides by negative 4. Actually, copy the negative 4x, copy the negative 3, then divide both sides by negative 4, because we're going to have to reverse the direction of the inequality symbol because we're dividing both sides by a negative number. What is negative 3 divided by negative 4? It's probably going to prefer the 3/4 to the 0.75. So, may not ask us for the number line here, but if we have 0, 1, 2, negative 1, negative 2, this is going to include the 3/4, and it's going to be everything to the left of it or to the right of it? To the left of that 3/4. So if that 3/4 is right there, we're going to shade it to look like this. In interval notation, 3/4 is the left-hand endpoint or the right-hand endpoint? It's on the right. So when you write the interval, 3/4 goes on the right. And then because it's unbounded to the left, negative infinity goes on the left. I wonder if there's anything special about the way we have to enter this because it's a fraction. Open parenthesis, negative. What's the shortcut for typing the infinity? No, there's a shortcut. Front slash INF. Front slash, oh, no, I don't want that. Where's the front slash? Front slash INF. There it is. Comma. Maybe the fraction. 3. And then 4.
Or you can just type in 3 with a backslash.
Or 3 \4 will give us the fraction. And then it includes the 3/4, so then the square bracket. Check it. All right. Next question. A little bit more of the same, but the square root of 9 plus x, there are a couple of issues with this. First issue has to do with the radical. Issue number 1. 9 plus x has to be greater than or equal to 0. That's necessary. It's just not sufficient. Because what we'll see is that negative 9 satisfies this inequality, but negative 9 is not in the domain. What's wrong with negative 9?
Denominator can't be greater.
That's issue number 2. Issue number 2. We're going to take the square root of that 9 plus x. And when we take the square root of that 9 plus x, it's not allowed to equal 0. So issue number 1, we've got to have a real number in the denominator. Issue number 2, that real number in the denominator better not be 0. So if both these issues are satisfied, we're going to be good. To satisfy issue number 1, we can subtract 9 from both sides. And x has to be greater than or equal to negative 9. That's necessary, but it's not sufficient because we have this issue, the second issue with negative 9. Issue number 2, if we square both sides, 9 plus x better not be 0. So x better not be negative 9. Both these issues have to be satisfied. So if on the one hand, x has to be greater than or equal to negative 9, and on the other hand, x is not allowed to equal negative 9 itself, what can we conclude?
Has to be greater than negative.
Right. Put both those issues together. In fact, join them with the word and, because they both have to be satisfied. X is greater than or equal to negative 9, and x is not negative 9. That means x is strictly greater than negative 9. So the interval is negative 9 to positive infinity. It cannot include the negative 9. Front slash INF, close parentheses. Check it. Here's another one of the dreaded instructor-created questions. Okay. Instructor-created question. I couldn't find a MyMathLab question that asked this just the way I wanted to. In fact, I wanted it to be free response. I really tried to get this to be free response, but try as I did, it would let me type in the answer, but it kept telling me, one of the situations was, you typed this, and the answer was this, and they're the same, but it's wrong. So I went with multiple choice. So let's see if we can do this. Again, 2 issues. Issue number 1. Let's see, the square root. When we take the square root, we got to get something real. So issue number 1, 9 plus x must be greater than or equal to 0. Got to take the square root, got to get a real number. In this case, I think negative 9 is actually okay. What if x is negative 9? You get 9 plus negative 9 is 0. The square root of 0 is 0. The denominator then is 12 minus 0. That's fine. That's 3. So you get, no, that's 12. 12 minus 0 is actually 12, right? So you get 4/12, or 1/3. There's a 3 in there somewhere. 1/3. All right. So nothing wrong with negative 9, but there is something wrong with something or other. So let's address issue number 2. 12 minus the square root of 9 plus x better not be 0. And there's some other value of x that maybe makes that 0. Issue number 1, subtract 9 from both sides. X has to be greater than or equal to negative 9. The other one, if we add the radical to both sides, it means whatever the square root of 9 plus x ends up being, it better not be 12, because we're going to subtract it from 12, and we don't want to get 0. So that wouldn't be good. What value, can you just stare at this and find the value that makes 9 plus x have a square root of 12? Well, it would make 9 plus x itself be 144, because 144 is a number that has a square root of 12. So x better not be 135. So on the number line, we're looking at this. We're looking at -9 and maybe a negative, well, I'm careful. I'm going to draw this to scale. I have to be extraordinarily careful. -9 is a key point. 135 is also a key point. X is greater than or equal to -9 would mean it's at -9 or to the right of -9. But somehow, when we get to 135, we've got to leave that out. 135 makes that denominator exactly 0. So we've got to leave that out, and it's going to look like that. But just on the other side of 135, it's going to be okay. So pick up with 135 on the other side and go out to positive infinity. So if we want to write this, it's two non-overlapping intervals, and we have to include both of them. We have to include the half-open interval from -9 to 135 and the interval from 135 out to positive infinity. And to indicate that it's everything in either one of these intervals, we use the symbol for union. So it's going to be this one. Hopefully it likes the C part. And it does 6 minutes and change. Let's look at a compound inequality. So not everything will have to be new next time. Remember when I don't remember seeing any compound inequalities in high school. I ran into one of these in one of the first math classes I took in college, and I thought, that's strange. I wonder what that means. A good word, preposition to associate with the compound inequality is the word between. Between, it means the same thing as the inequality is written, as it ordinarily you would think of it, where numbers lie on the number line. You see the x plus 2 written in between. -8 and 11, it simply means in order for x to be a solution of this, the value of x plus 2 has to be between -8 and 11. And it really means two things. It means, on the one hand, x plus 2 has to be greater than -8. So you could say -8 is less than x plus 2. And it also means x plus 2 must be less than 11. If x plus 2 is greater than -8 and x plus 2 is less than 11, then x plus 2 is going to be between those two numbers. Now, if I were solving these inequalities separately, I would be subtracting a bunch of 2's. I would be subtracting 2 from both sides there to get -10 is less than x. And a couple more 2's. I would subtract 2 here, and I would subtract 2 here, so that x is less than 9. And carry the and down, because both of these have to be satisfied in order for the inequality, the compound inequality, to be satisfied. If -10 is less than x and x is less than 9, then x is between -10 and +9, and we're looking at the open interval. I say open because it has parentheses on both sides. It does not contain either one of its endpoints. The open interval, -10 to 9. Now, to solve a three-part inequality, it's not necessary to break it apart and to use the word and. We simply write the three-part inequality. Rather than subtracting 2 from both sides of one of them and both sides of the other one, we just subtract 2 from each part. And if we subtract 2 from each part, that will give us an equivalent inequality. Subtract 2 from the left part, subtract 2 from the middle part, subtract 2 from the part on the right, and we get immediately negative 10 is less than x, and that's less than 9. So if x plus 2 is between negative 8 and 11, x itself would have to be between negative 10 and positive 9. Let's make sure it likes it. And the graph, make sure it has parentheses on both sides. B. There we go. The next one involves an extra step and is probably more typical, actually, of what you would see on the test. We've got 2x plus 1 has to be in between negative 4 and 7. So a couple of steps. First step, let's isolate the x term in the middle. And second step, that'll be a 2x in the middle. Let's, divide each part by 2 so that we just have 1x in the middle. So subtract 1 from each part. Negative 5 has to be less than 2x, and that has to be less than 6. And then I want to divide each part of this by 2. That's what I'd do if I broke it apart into 2 separate ones. Divide each part by 2. So copy the negative 5, copy the 2x, copy the 6, divide each one by positive 2. Leave the inequality symbols the direction they're pointing or reverse them. We're dividing each part by positive 2. If we were dividing each part by negative anything, we would reverse them. We would reverse both of them. So negative 5 halves must be less than x. X must be less than 3. Another open interval from negative 5 halves to 3. And in less than a minute that we have, let's make sure MyMathLab likes it. So negative 5 and then backslash 2 for the negative 5 halves, and then 3, and then close the parentheses, fingers crossed. Good with it. All right.